we have these multiple choice questions. If f of x is given by x, f of x is equal to x, the inverse of f, which is f to the power negative 1, could be represented by one of these. So if the f of x is going to be equal to x, if this function f of x is equal to x, let's call this y, meaning that y is going to be equal to x. Of course, already here x is already the subject of this, so meaning that x is going to be equal to y. So if we to flip those, y will still be equal to x. What does that mean? It means that the inverse of x is still going to be x, and our answer here is A. Another here, the inverse of this function f. This function f is in form of ordered pairs 1 2 2 3 3 4 4 1 this and 5 2 would be a function if the domain of f is limited to. Now they're asking us this would be a function if the domain. Now by the domain we are talking about the values of x. We have 1 there, we have 2, we have 3, we have 4, and we have 5. 1 2 3 4 5. Now this function, let's call this a relation. The inverse of the relation f, this would be a function if the domain of f is limited to, and they've given us these alternatives. Now, first of all, what is the inverse of these ordered pairs? Let's first find the inverse, because the question is talking about the inverse of this. So let's first find the inverse. Of course, the inverse of this is going to be given by, this is 1 2, the inverse of this point is, or the reverse is 2 1. Then here it is, this is 2 3, it means the inverse here is 3 2. Then this is 3 4, meaning the reverse is 4 3, or 4 3. Then here the reverse of this, or the inverse, is 1 4. Then this is 5 2, the reverse is 2 5. So now actually the question is talking about the inverse of these ordered pairs, and the inverse of these ordered pairs is this one right here, and they're telling us that this inverse here would be a function if the domain of f is limited to a certain set of numbers. Now let's look at the domain of this inverse. If you look at the domain of this inverse, we have 2 right there, we have 3, we have 4, we have 1, then we have 2 again. Now what do we know about a function? We know that a function is supposed to be one input going to equivalent to one output. One input is corresponding to one exact output. If a certain input is having more than one output, then it's not a function, it's just a relation. But now let's look at this relation here, the inverse of this thing. We have 2 3 4 1 and then 2. So you realize that we have two inputs here. We have 2 1, we have 2. We have a 2 here and a 2 here, but the input of 2 is giving us an output 1 here and an output 5 here. So meaning that this is not a function. This ordered pairs is not a function because we're having an input 2 giving us two different outputs of 1 and 5. So it means that if we are to make this a function, we have to eliminate one of these, because the uniqueness of a function, or the major characteristic of a function, is that one input corresponds to one exact output, not one input having two different outputs. So it means we can either eliminate this or that. So that the question is that what would be this inverse would be a function if the domain, that means if the values of x of f, the values of x of this one are limited to this. So if this thing is to be a function, it means that the values of x that are corresponding to these two, one of them has to be eliminated. So it means that we are either going to eliminate this or that. So if you're to come back to this 2 1 corresponds to this, and this 2 5 corresponds to that. So it means that if this is to be a function, we have to eliminate f. The domain of f should be limited to. Now it either has to be we either have to eliminate one or we have to eliminate 5, one of those two. We eliminate either 1 or 5, and if we eliminate this one and maybe therefore we kill this point, it would mean that the inverse is a function, or we eliminate this. So we'll come here and see which one has been eliminated in our answers. So the domain would be limited to 1, 3, 5. No, that is not it. A is not it. Part B, we have 1, which is that, 2, 3, and 4. This one, B, looks correct. C is 1 and 5. These are the ones we are eliminating. C is not. Part D is 1, 2, 4, and 5. So both are still there. C, D is not it. Then we come to part E, is 1, 2, 3, 4, and 5. Part E includes all of them. It's not. The answer here is B. That B is having 1, 2, 3, and 4. So meaning that we've eliminated this one. So part B is the answer here. We have these multiple choice questions. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia, helping you manifest excellence.